Hey everyone, and welcome to this explainer. Today we're jumping right into Unit 3, which is all about learning and machine learning. Specifically, we're unpacking a really fascinating lesson. For those keeping track, the exact lesson ID is STEM-AI-STEM-AI-Unit-3-Lesson-Pack-04 Reasoning Application Task Video Overview. And the title is Reasoning Application Task Video Overview. We are going to figure out exactly how artificial intelligence thinks, how it learns, and most importantly, how we can actually make sure we trust it. Let's dive in.
First things first, let's bust a massive myth right out of the gate. A lot of people just assume that an AI is this rigid set of rules, that it reasons the exact same way every single time, totally regardless of whatever new information you give it. It's super easy to think of computers as just blindly following a strict recipe. But the reality, especially according to the experts over at the OECD, it's entirely different. AI systems based on machine learning actually teach themselves over time. Their reasoning isn't frozen in place, it constantly evolves and shifts based on entirely new data.
So to really get how that evolving reasoning works, we kind of have to look under the hood at how an AI system is actually built. The OECD breaks this down into three main parts. Step 1, sensors. This is simply how the AI collects raw data, basically taking in the world around it. Step 2, operational logic. This is where the AI interprets all that gathered data. And step 3, actuators. This is how the AI actually changes the environment based on its interpretation. So it's this continuous, ongoing cycle, right? Perceive, reason, and act.
All right, so the absolute core of that whole cycle is that middle step, operational logic. When we talk about an AI reasoning, well, this is exactly where the magic happens. The operational logic is essentially the brain of the entire operation. It's a step that takes all the raw data collected by those sensors, interprets it for a specific goal, and then provides a clear output. And that output? It could be anything. A movie recommendation, a prediction about tomorrow's weather, or even a split-second decision in a self-driving car. This is literally where the AI connects the dots.
There's this great quote directly from the OECD that really hammers home how this reasoning actually works in modern machine learning. It says, in statistical AI, machines deduce a trend from a set of patterns. AI systems based on machine learning teach themselves over time. Think about what that means. The AI isn't just following some static checklist written by a programmer 10 years ago. It's looking at massive amounts of data, finding the hidden patterns within it, and using those patterns to deduce trends. And as it gets fresh data, those patterns shift, and the AI's reasoning actually changes right along with it. It is continuously learning.
But hold on a second. Let's really think about the implications here. If an AI system is constantly teaching itself, and its reasoning is constantly changing based on whatever new data it gets, how on earth do we know we can trust it? I mean, if the operational logic isn't permanently locked into place, how do we guarantee the decisions it makes tomorrow are going to be just as safe and accurate as the ones it made yesterday? That is the million-dollar question we have to solve. And that brings us to the ultimate toolkit for keeping AI trustworthy. To solve this whole problem of shifting reasoning, scientists rely on something called the NIST AI Risk Management Framework, or AIRMF for short. The National Institute of Standards and Technology developed this framework to help manage the real-world risks associated with AI. It's built around 4 core functions: govern, map, measure, and manage. Basically, these 4 functions are how human beings keep a structured, watchful eye on these learning systems.
Let's zoom in on just one of those functions right now, because it's absolutely crucial for our trust in AI. Let's look at measure. In the NIST framework, measure is the step where we rigorously test and check the system. Because we know the machine learning model is out there teaching itself and updating its reasoning, we have to constantly measure its outputs. We're verifying, is this AI still accurate? Is it still functioning safely? The measure function is essentially our safety net. It catches the AI if its changing reasoning starts to drift off track.
Section 1. Worked example. The cafeteria predictor. Checking AI reasoning.
Okay, picture this. Imagine your school has a brand new AI system running the cafeteria. Its main objective is to prevent food waste while making sure nobody goes hungry. So, the AI looks at historical data, past checkouts, the day of the week, regular student attendance, to predict demand. Based on all those past patterns, the AI's operational logic reasons that exactly 100 students are going to buy pizza this coming Friday. It's deduced a perfectly logical trend from the patterns it's seen before. Simple enough, right? But boom, new data alert. A massive snowstorm hits unexpectedly on Friday morning. The
The buses are delayed, half the neighborhoods are snowed in, and school attendance completely plummets. This is entirely new, real-time data being fed directly into the AI sensors. That old pattern it relied on, that Fridays always equals 100 pizzas, is suddenly being totally wrecked by a brand new, unexpected variable. So what happens next? Well, first, human operators step in and apply that NIST measure function. They compare the AI's confident prediction of 100 pizzas against the actual, mostly empty cafeteria. Okay, the AI got it wrong this time. But because it's a machine learning system, it actually takes this new data, the failure, the snowstorm, the low attendance, and it updates its operational logic. It teaches itself a brand new pattern. When there's a major weather event, pizza demand drops, no matter what day of the week it is. By measuring the system, we make sure it learns the right lesson and updates its reasoning safely for next time.
Section 2. Application Task. Your turn. Apply the reasoning check.
All right, you've seen how it works with the cafeteria. Now it is time for your application task. Let's put on our AI practitioner hats for a second. Here's your scenario. Your school library uses an AI to recommend books to students based on their past checkouts. Out of nowhere, a brand new sci-fi series drops and becomes wildly popular. Literally everyone is talking about it. Based on what we just learned about machine learning and that NIST framework, I want you to figure out two things. First, how is the AI's reasoning going to change based on this new trend? And second, how would you, as the human operator, apply the measure function to check it? Take just a quick second to think about how you'd answer that.
Okay, let's break it down. Remember, this whole thing is all about perceiving, reasoning, and acting. Because this library AI uses machine learning, its reasoning is naturally going to update. It's going to ingest all this fresh data of students suddenly checking out this new sci-fi series, deduce a totally new trend, and start recommending sci-fi books way more frequently to other students. Its reasoning has officially changed. But to make sure it's doing this correctly, you have to apply the measure function. You'd check to see if the AI's new sci-fi recommendations actually match what the students end up choosing to read. If students keep rejecting the recommendations, you know the AI's reasoning needs a tweak. You measure it to maintain that accuracy and trust.
So, what is the big takeaway for this explainer? It's that AI reasoning is absolutely not static. Operational logic in machine learning depends heavily on the patterns it continually learns from brand new data. It is always teaching itself. And precisely because it's always changing, we have to rely on tools like the NIST AI Risk Management Framework, and specifically functions like measure, to constantly check its outputs. That's how we keep it trustworthy, accurate, and safe as it learns and grows. I want to leave you with one final kind of mind-bending thought to chew on. Since machine learning systems are constantly updating their reasoning based entirely on the data they get from us and our environments, what patterns are we teaching them today? Every single piece of data is a new lesson for an AI. Thank you so much for exploring this with me today on this explainer regarding reasoning and application tasks. Stay curious, keep asking questions, and I'll catch you next time.